Hey guys, Mr. Palmer back with part 5 of our momentum review. This is number 8. This one involves another collision conservation of momentum. It happens to be an elastic collision problem. So that is, we're going to have two objects before and two objects after. So let's do the setup for this one. We have two objects that are going to collide. If we have two objects, when they collide and separate, we can calculate their momentum before, and we know that via the conservation of momentum, they will be equal after. So if we sum up their momenta, they will be exactly the same before and after the collision. In this case, we're looking for the mass of the second ball, and you're given some velocities and the mass of a first ball. It's really important to look at the directions. One of these is north, this one is south, and we have another velocity over here that is north again. So let's pay close attention when we're setting this up. We have a 5 kilogram ball. It's going to be our object number 1. I'll leave out the units for now. It's traveling 10 meters per second north. North we call positive, so I'm going to call that positive 10 meters per second. The second object, we don't know what the mass is, but it tells us it's initially at rest. If something's at rest, that means the velocity is going to be 0. And if we add up these two momenta, afterwards they should be the same again. So it tells us that after the collision, the 5 kilogram ball is going 4 meters per second south. So the mass is still 5, except its velocity is now negative 4. And it tells us that the second object, the second ball, is traveling 3 meters per second after the collision, but we don't know what its mass is. So we're just going to substitute in the m2 for the mass, and I'm going to call this positive 3. It's positive again because north is positive, the south was negative. All right? So if we set this up, 5 times 10, that's going to give me 50 kilogram meters per second. I'm not going to put my units in. Plus 0. I don't know what the mass is, but I would multiply by 0. That gives us 0. This is going to give us negative 20 kilogram meters per second. And then this, we don't know what the mass is, so we're just going to leave that as a variable for now. So that's going to give us 50 equals negative 20 plus m2 times 3. We're going to add 20 to both sides, or that is subtracting negative 20, to give us 70 on the left equals m2 times 3, which gives you a mass for your second object of 23.3 kilograms. Right? Pay close attention to the positives and negatives. If for some reason you wound up with a negative mass, that would tell you you're definitely doing something wrong. Okay? Again, conservation of momentum, and I'll be back with two more dealing with explosion problems.